we created these files and we tried saying like what exactly happens when we want to see the header and so on. So I will readdress few terminologies. So we use this readelf, okay, to search for symbol table. Okay. So you can see it shows symbol table. Okay. There a dot out, as well as like same symbol, similar kind of symbol table can be seen with respect to your dot o2, and this is symbol table. Similarly, we tried finding out what you can call it as magic number for the file. So this is for your object code, okay, which is ELF. So you can see 75454C4600. So if I open similar thing and if I write read ELF dash H a dot out, is there any change by the way in both the magic numbers? Can you see
No,
that?
sir.
Okay, so that's why it says ELF. Only whether in what form it is. So rest of the things will be added there. If you compare point to point, the type of the file is relocatable, okay, and the type of the file in this case is dynamically linked, okay, shared object file. Rest of the things like depending upon what exactly you have and what exactly you don't have, everything will be added. Okay. Okay, so let us move further and let us address another aspect which we saw in previous session. So we tried working with this strip, okay, which was used to remove the unnecessary symbols, okay, as well as if you recall we tried finding out how can we generate first.s, how can we generate first.o. So the consideration that we applied was gcc-s-m32 first.c will generate what you can call it as an assembly file. Okay, so you can see this is assembly code generated. So if I write file first.s, then it says assembly. So the command that I applied was this. Similarly, like when I apply first.-c option, so it generates what you call it as an object code. Okay, so these are intermediate files generated while creating an executable. So there should be some other aspect also involved. Like for example, whenever you were taught, say, C compiler, you must have seen that like there is something called pre-processing, a preprocessor. Now what happens in that phase then? Like, because when we talk about translation from source to an executable, there could be multiple things involved there. But at some point of time, like what would be the first stage generally, if at all the translation is to be done? Okay, so let me try to address it. So for example, let us try say Emacs. Let's create this file. Let us write hash include, sorry, yeah, hash include stdio.h. Hash define max 2. So main printf So let us say this is our code. So simply what we did here is we are using constant declared here. Now when I create an executor, when I create an object code, so let me create it. Let me first create assembly code for this dash m32 28 dash. Sorry, mistake. Okay, now let me see whether if I generate, if I try to see this, and let me first create that object code too. If I try to see symbol generated there, okay, can I see max there?
Hello,
Yeah, yes,
sir. Can you speak little loud?
I'm not audible. Let me see like if there is any issue. Am I audible now? Am I audible?
Yes,
Yes,
sir.
sir.
Okay, okay. So what I said was I wrote this code. Okay, so let me show you this if it was not audible to you. So I wrote this code. I declared a variable max through hash define. Okay, and I'm using that max there in my code. Now when I try to say generate an object code through this command, and if I try to see symbols added into my object code, I cannot find max. Like we already saw that as a local variable a is there, this would definitely would not be part of what you can call it as the symbols because it is a local variable, but globals should be part of this. Now where exactly that max went then? Okay, let me try to see even say my .s file. Let us see, like we can see there is RO data, read only data, that's what we talked about earlier. Value of a is %d. Okay, so this is where your first line is, your code started, and see whether can you see max there. So if I move further, what we did was the value that we gave to max. What was that max value? Max value was 2. So I can see here this 2 is assigned to my local variable. This was my local variable created. Okay, and we will see like how what exactly is to be done. I at no place can see that my variable max which was added above is shown there. No. In your data section even like if I see .lc0, this was added in RO data. So there is no thing called as data section here. Correct? There is nothing called data section because I assigned value 2 and value 2 can be seen only like for that variable when I assign that as an assignment statement through my code at this point a equal to 2. So what exactly happened there? So if I want to see what my preprocessor did, so what command you apply is this. You write here -e, capital E. Fine. Let me take this. Let me first show this on screen. So this is big output. So I can see this is my code. Correct? Now max is not shown. I can see that a equal to 2 is directly written. Correct? So if I go above, okay, like this would be difficult for you people. So what I will do is I will direct it to a file, output to a file. Okay, and let us see this less p.txt. So this is your preprocessor's work. So it is showing you that majority of things are coming into picture, like header start search, header start.h, so stdio.h, predef.h, so on. So stubs.h, features.h, all these header files are used to generate this code. This is a pre-processed version of your C code before giving it to generate an assembly code by to the compiler. Okay, now try to see whether can we see max there. So I'm scrolling down little slowly so that you also can find out whether max is found there or not. So I can see there is something called it max, but it is not my variable. Correct? It is not my variable because I declared it as a capital case. Like all characters in my variable name are in capital case. So let me go below and try to see whether can you see that definition of max. So we got stuck some structure. Now this is not related to my program at all right now. This is added by preprocessor. These are all lines which you can see. Now see, you wrote only at least 5 to 6 lines code, but when it is pre-processed, these many lines were added there in that code. Can you see max? Still no. Right, let us go below. So instead of doing like this, okay, let me write, say for example, like this, grep. If I write grep printf, I can see those lines. That means it is searching them in that file, but it definitely could not locate this max. Correct? So one can see, like when I try to see the files, this was a redirected file which was created by me by making use of this option. This was my command. GCC dash capital E dash M32 file name dot C greater than P dot txt. So that what are the output of this command which is shown on the screen should be stored as a file. So if I press enter here, it does directly shows me on the screen. But when I redirect it to say p.txt, it would be written in that file. So this is a pre-processed version. So whenever you give your input program for compilation purpose, first phase is pre-processing. If a macro is there, macro will be pre-processed. Then what are the file that got generated would be taken by compiler to generate .s file. So when that file was created, what are the file which was created? So like if I start from say for example understanding syntax of that code. Okay, so like the way I could see this code was written. So I as a translator I will go line by line. So yes, is this valid? Yes. Is this valid? Yes. Is this valid? Yes. So on. When I don't see any errors or warning, then my task would be to translate this code into assembly code. Now to do this, nearly more than 80 times your code would be visited. What I said, nearly 80 plus times your code would be visited by your compiler code. Now, when I say your code, I mean to say this source code. What is the source code that you can see now on the screen? That source code would be revisited by your compiler code to generate .s file. In between, like when I say 80 plus, so suppose let me take one example. Let me share my Windows screen with you. Is it visible?
No, sir.
Okay. Yeah, now it should be. Yes, now can you see this 1, 2, 3, 4? So let us say this is first time it visited. So after visiting my code first time, it would be generating something. Suppose it is small a. Okay, one of the file type. Like after, say for example, uh, this is where my code is. So my code is code.c. This code would be taken and given to this first time visit to this code. This code would be getting translated to something. Suppose its version is A, version number 1. This A would be taken by 2 and this will generate, say for example, B. This B would be taken by 3 to generate C. C would be taken by 4 to generate D, and so on. Lastly, like let us assume that lastly I am getting code.s. Okay, now though I have written here only 19, so there is dot dot dot. I don't know how many steps would be there to really translate my code from code.c to code.s. So these files would be created. These files are temporary files. These are not stored anywhere right now. But if I can debug the compiler's code at the time of compilation, when you write gcc-c, if I debug this whole process, then I can see definitely these files. But then I have to work with compiler's code. Now what we are doing, we are using binary code of compiler to only translate your source code to a .s file. Now on the similar fashion, if at all I wish to see like what files are generated, so what we saw was this. What we saw was this thing. Like when we create a file, say for example, if I take first.c, first.c would be generating something called that first.s. Then it can generate first.o. And after some time, depending upon your command that you fire, it would be generating a.out. Now there is no way for us to rather right now. We haven't seen any way right now to see this code generated as a file. How can I see that? So now note down this command. So let me delete all .os, a.out, my.exe, third, rmp.txt, first.s. Now I have only these files. Correct. Now how many files are there? Like though it is saying 32, but I can see that these are the ones. And even let us delete this start till that. I have only these files with me. Okay, let me remove this 2802.txt. I have only these 4 source codes in my current directory. Fine. So let me write this gcc-m32 save -temps. I simply applied this command. Now let us try to see what exactly it shows. How many files are generated? You can compare the top output of ls-l and current output of ls-ltr, like only to show you in a sorted order of time. You can see this was generated, like you may say all of them are generated at 9:43, but see the order. First.c was there, it generated first.i. This first dot I, after that first dot I, first dot S is generated, then first dot O is generated, and then A dot out is generated. So these are the files, the way that I was showing earlier to you, like code.c was taken, then it was taken by 1, gives A is taken by 2, gives B is taken by 3, gives C, and so on. Similarly, this is what I can see. Now, in between first.c and first.i, there might be hundreds of again files generated. We don't know. Even from first.i to first.s, because our target was only till this, the compiler's process. Still .s only. So, like if at all I have to deal with this whole strategy of compilation. So what I do then, let me write now this. Code.c is taken, okay, which generates. Okay, let me show you now through the screen. 1 minute. Code.c would be taken, and now it will generate code.i. Let me delete these far away. Now you understood, correct? Then this will generate code.s. This will later generate code.o. This will later generate your a.out. So GCC took this. GCC took this code.c, generated code.i. This was by your compiler, preprocessor. GCC took code.c. Through the preprocessor version, it generated .i. Through the compiler code, it generated .s. This .s was taken by something called as GAS, GNU assembler, generated code.o. Okay, and then there was a linker called LD internally, which generated your a.out. So now let me say this. So code.c was here, was given to GCC. Okay, GCC took it, gave to preprocessor, gave code.i. Okay, .i. This code.i was taken by your compiler code, generated this file code.s, was taken by GAS later, generated code.o, and this code.o was taken by your linker, which further generated a.out. So this is the complete path which is visible to the user, the person who is compiling the code or generating an executable. So from this path, like if I see, to reach to this line, there are different number of passes. Pass, I mean to say, how many times your code was visited by your compiler code. Now, when I broadly said here compiler, there are hundreds of different routines used inside to translate your code to code.s. Like you are learning theory of computation, or some of you already did that in your bachelor's. You must have heard something called as parse tree. Your code would be parsed and would be verified for that, like whether is it syntactically correct or not. That task would be done, like parse tree, abstract syntax tree, different terminologies are there which would be used internally. So there comes even pre-processing as well through the lex. Okay, syntax check, syntax would be verified. Syntax analysis would be done by this. Then there comes a parser. These are the terminologies used by your compiler inside, no matter which language you are using. Which language you are using to achieve that goal. So now, how to say that? The way they think that I'm saying now that there is something called as LD, there is something called as gas. Can I view them? Can I see them? Okay, let me try to show you. So if I write man AS, okay, so you have to write man AS. So you should be able to see this, the portable GNU assembler. So actually it is gas. The syntax that you see here in your file, this is syntax of GNU assembler, gas. Right? This whole code is written in gas code, gas syntax. This code was taken by your AS to generate .s, sorry, to generate .o. So let us write man LD GNU linker. So you can see LD combines number of object and archive files. What is archive? We would be talking definitely towards end of this course, last week of your course. So this LD is used. So how can we verify whether LD is used there? So let us write test.c int abc. So if I try to write gcc test.c-m32, can you tell me that will this generate an executable there? Will it generate an executable there through this code? If sy, if no y. Okay, how many of you are towards yes? Will this generate an executable? How? What is my code? I'm writing hash include stdio.h int abc printf. This is trial return 0. Done. Will this generate an executable? How many of you think that it will generate an executable? You can raise your hands. Okay, Tushar is saying it will generate an executable. Yes. Others? So can I assume that others are towards that side, like it will not generate an executable? If you wish to add your input, if you want to join Tushar, you can raise hands. Okay, since Tushar is only one who sees or who assumes executable would be generated. Let us try to do so. Let us try writing gcc-m32 test.c. Now see the error that is shown. Oh, sorry. See the error that is shown. USR bin LD in function start undefined reference to main LD returned exit status, and that proves existence of this linker. That this linker is used internally to generate an executable. So we simply write GCC. This doesn't require any other program included there like gas or probably LD. It is already taken care of. To show you that part. So we may not be sure about where exactly these are included, because we have to see then source code of GCC, and our task is not to work with that source code of GCC. Like if at all you wish to see, you can go to Google and simply write GCC GitHub. Okay. Now the way that we write source code, the way that we write the code, the source code also can be seen. Like this is source code of GCC. So I simply wrote this GCC GitHub. So this is what I got. This is source code of your C compiler, GNU C compiler. Now you may say, how many files are there? So many. So if I say, for example, if I go to, let us go to say one of the directory. So, okay, let us go here. GCC. There are other things like your C compiler, GCC can be used to translate the codes written here. Just in time, Object C, P, C plus, C family, ADA, okay, Fortran. Let us go to this C. So if I open one of the files, so this is source code of my C compiler. One of the file from that whole branch or whole tree. This is the directory tree or hierarchy containing these all files, all directories containing huge number of files. This whole code was compiled together, and then your GCC, the command that you use on your shell, is added. And ultimately it is useful for you in that case. Correct? Are you with me?
Yes, sir.
So
Yes, sir.
we have seen that whenever we try to compile the code, there are different files which can get generated. But if at all we want to see few of them, the command that we are going to use is, can somebody tell me to see those files? You write this command. gcc-m32-save-temps first.c, which generates these 4 files in one single shot. And definitely, like if I try to write say file first.i, it says C source ASCII text first.s, assembler source first.c, C source first.o, elf 32-bit, and then a.out. Each one is having like its own form, because because the file was not created. That's why that a.out could not be there, seen there. Okay, because we can see that there is error. That's why. So GCC first. Okay, let us write that save temps. Then you write file a.out. You can see the command. Okay, so what we saw today, whenever a code is taken, like while I'm speaking, if I speak too fast, what will happen? Some of the words you may miss. Now, as it is, it would be available as a recording perspective later. It is easy for you to really listen it again and understand it. But if it is a regular class, if you miss and if you don't ask the question, everything is lost. It would be difficult for you to remember or understand what exactly is happening there at that side. Fine. Okay, so I will stop here and we will continue.